Hi everyone, welcome to our vlog. Today we are diving literally and figuratively into the main causes of pollutions, the oxygen-demanding pollutants.
Ew, what's this? It looked like just dirty water, but what's really happening here could kill a fish.
Yup, it's not just about the dirt you see, it's something you can see. The oxygen that fish needs to survive.
So what are oxygen-demanding pollutants? Oxygen-demanding pollutants are organic materials such as food wastes, sewage, and decaying plants that end up in rivers and other bodies of water. These materials enter the water, the microorganism starts breaking them down. But here's the catch, they use oxygen to do it.
I eat waste.
I need oxygen!
Sorry, fish. I need oxygen too.
Wait, leave some for me!
This process increases what's called the biochemical oxygen demand, or BOD. When BOD increases, the dissolved oxygen, or DO, in water decreases, making it hard for aquatic life to survive. Let's follow the journey of a river affected by oxygen-demanding pollutants. First, we have the clean zone, which requires a high DO, or dissolved oxygen, of around 8 parts per million, or ppm. With this, it results to a clear water which can be used as a habitat for the fishes. Next is the decomposition zone, where pollution or the organic waste is introduced, microorganisms increase to decompose the waste, and DO starts to drop as oxygen is consumed. The BOD also rises sharply, and the organisms which are pollution-tolerant fish such as carp and gar starts appearing. Next is the septic zone, which is the worst water quality. This is where oxygen levels may reach zero, which promotes anaerobic conditions. Bacteria, fungi, sludge worms, and other organisms that can survive without oxygen-dominated water. This is where fish die or are absent. Then we have the recovery zone. As waste is broken down and flow continues, the organic matter decreases. Oxygen levels starts to rise again, and pollution-tolerant fish like carp and gar returns. And lastly, we have the clean zone, which is also known as the downstream. This is where water recovers and returns to a normal oxygen levels, which is about 8 parts per million, or ppm. And aquatic life diversity increases again, with clean water organisms reappearing. This is how oxygen-demanding pollutants create different zones in a river, from healthy beginnings to dead zones, then slow recovery.
Now, oxygen-demanding pollutants are common in areas that has a lot of human activities and poor waste management.
First, we have urban areas, which are sewages from homes and drains which flows into rivers. Next is the industrial zones, which are waste from factories and food processing plants. Farms and livestock areas, where animal manure and fertilizers washing off after rain. And lastly, we have coastal towns, where market runoff and canals bring waste straight to the sea.
That's why proper wastewater treatment, like in sewage treatment plants, is so important. Without it, our rivers literally can't breathe.
When the dissolved oxygen drops too low, aquatic life starts to die. You'll see fish kills, bad odors, murky or blackish water, and loss of biodiversity.
So what can we do in order to stop oxygen-demanding pollution?
Well, number 1, you treat wastewater before releasing it. Number 2, don't throw food or organic waste into canals. Number 3, support sewage treatment projects and proper drainage systems.
Remember, keeping our waters clean means keeping our oxygen levels healthy for us and for all aquatic life.
So that's it for a vlog about oxygen-demanding pollutants.
They may be invisible, but their effects on aquatic lives are deadly.
And so let's do our part to keep our rivers and seas clean. Together, protect water, protect